Biconditionals and Definitions. Objectives: to write biconditionals and recognize good definitions. A biconditional statement. A biconditional is a single true statement that combines the true conditional and its true converse. You can write a biconditional by joining the two parts of each conditional with the phrase if and only if, sometimes shortened to IFF for if and only if. Example 1 says, what is the converse of the following true conditional? If the converse is also true, rewrite the statement as a biconditional. If two angles have equal measure, then the angles are congruent. So the converse is going to be when we flip them, saying if Q then P. So we're going to say if two angles are congruent, then the angles have equal measure. Since both are true, we can say two angles have equal measure if and only if the angle measures are if and only if the angles are congruent. If and only if. The symbols, notice this way we have two arrows going back and forth, and we're saying that it's if and only if. And this is if the conditional statement and the converse are true. Example 2. What are the two conditionals that form this biconditional? Two numbers are reciprocals if and only if their product is 1. So we're looking at P and Q because it's P if and only if Q. So the first one we can say is if two products are reciprocals, then their product is 1. And now we can flip-flop this and write the converse and say if the product of two numbers is 1, then the numbers are reciprocals. A good definition. Good definition is a statement that can help you identify or classify an object. A good definition has several important components. A good definition uses clearly understood terms. These terms should be commonly understood or already defined. A good definition is precise. Good definition should avoid words such as large, sort of, and almost. And a good definition is also reversible. That means you can write a good definition as a true biconditional. It says, is the definition of a straight angle reversible? If yes, write it as a true biconditional. So the statement says a straight angle is an angle that's measure is 180. So the first conditional statement would be if it is a straight angle, then the angle measures 80 degrees. That's true. Now, is it reversible? If an angle measures 180, then it's a straight angle. That's also true. So we can write this as a true biconditional that says an angle is a straight angle if and only if its measures is 180. Example 4a, it says, is the following a good definition? Explain. A square is a figure with 4 right angles. Well, if it's a good definition, it will only apply to squares. Well, can you think of another figure that has 4 right angles? Well, let's see. If I draw a rectangle that's not a square, it will have 4 right angles. Is that a square? No, so this isn't a good definition. We have to add something to it. If we want a good definition of a square, we have to say it's a quadrilateral with 4 right angles and 4 congruent sides to be more specific about a square, so that way we can tell the difference between a square and a rectangle. Example B says, how can you rewrite the statement obtuse angles have greater measures than acute angles, so that it's a good definition? Now, most of you, if I ask you, what's the definition of an obtuse angle? You would say that an obtuse angle is greater than 90 but less than 180. So that's a good definition of obtuse. So we're going to say, for definition of obtuse is greater than 90, but less than 180. Lesson check. You need to do these 6 questions before you come to class so that way we can discuss them, and then you can get started on your Math Excel.